Hello, I'm teacher Ivan from Wuna Educational Services. We are still looking at the heat transfer calculations, that is A-level physics paper 1. Otherwise, this is our second episode where we are still looking at the heat transfer by conduction in solids. In our previous discussion, we looked at the definition of conduction and the mechanism of heat conduction in both non-metallic and metallic solids. Otherwise, we had a question as we were wrapping up. The question was, how comes that these metals transfer heat at different rates, besides the fact that they have the same mechanism of heat transfer? And our answer is thermoconductivity. Thermoconductivity is defined as the rate of heat flow at right angles to the opposite faces of 1 cubic meter of a material when the temperature difference across the faces is 1 Kelvin. However, in simple terms, we can define thermoconductivity as the rate of heat flow through a material per unit cross-sectional area per unit temperature gradient. The rate of heat flow through a material per unit cross-sectional area per unit temperature gradient. And from that definition, we shall derive our formula and the units of thermoconductivity. So, we shall consider a conductor of thickness L, cross-sectional area A, with its ends kept at temperature theta 1 and theta 2. And that will be our conductor. So the rate of heat flow per second is directly proportional to the cross-sectional area, meaning that as we increase the cross-sectional area of the material, the rate at which heat flows through that material increases. And also the rate of heat flow per second is directly proportional to the temperature difference. Temperature difference is given by the temperature near the source minus the temperature at the other end of the conductor. So, as the temperature difference increases, the rate of heat flow through this conductor also increases. And lastly, the rate of heat flow per second is inversely proportional to the thickness, meaning that as the thickness of the material increases, the rate of heat flow reduces. So, meaning from that statement, we get 3 factors that affect the rate of heat flow through a material. That is the cross-sectional area, the temperature difference, and the thickness. However, the temperature difference and the thickness is always combined to get what we call temperature gradient, as we shall see. So, when we write this statement mathematically, we shall summarize it as Q over T. Q is the temperature and T is showing time. So meaning that Q over T represents the rate of heat flow per second. Is directly proportional to the cross-sectional area also directly proportional to the temperature difference, but inversely proportional to the thickness L. And therefore, when we combine these three, we come up with this, where the rate of heat flow is directly proportional to the area and direct proportional to the temperature difference, but inversely proportional to the thickness. But when we divide the temperature difference by thickness, we get what we call temperature gradient. However, when we substitute the proportional sign with a constant, we shall get the rate of heat flow being equivalent to constant K times the cross-sectional area times the temperature gradient. And therefore, this constant K is what we are calling thermoconductivity. So, we shall now make thermoconductivity the subject, since it is our major concern in today's lesson. When we make it the subject, it becomes the rate of heat flow divided by area and the temperature gradient. And from this formula, we can also get the definition of thermoconductivity, which is the rate of heat flow through a material per unit temperature gradient per unit cross-sectional area. Please, that word should be cross-sectional area, not area alone, because we have two types of area. If you write area alone, you might be meaning surface area. So take a note about that. Still, from this very formula, we can get the units of thermoconductivity. This is how we shall get the units. So, from Q over T, Q is heat, and that is energy. So, is represented by joules. Over time, in seconds, that is joules per second. Then area is given as meter squared. Then the difference in temperature is given as Kelvin, because that is the SI unit of temperature, over the length, which is meter. So this meter will reduce the square, so that we come up with, and when we divide the joule by second, we shall get watt. So you can write joules per second, or we combine the two to get watt. Over, now this meter has reduced the square to a meter. So it is watt per meter per Kelvin. That will be our units for thermoconductivity. So we also look at the factors on which rate of heat flow depends. We've seen from the formula of rate of heat flow that there are three factors. That was the cross-sectional area, the temperature difference, and the thickness. However, the temperature difference divided by the thickness gives us temperature gradient. So we combined the temperature difference and the thickness to get one factor, which is temperature gradient. However, we also derived the thermoconductivity, which is now representing the nature of the material. And now this is where we get the reason as to why metals having the same mechanism of heat transfer have different rates of heat transfer. It is because of the nature of the material, or the thermoconductivity of the material. Each metallic conductor has its own thermoconductivity. That's why we have copper as a good conductor more than iron, steel, aluminum, among others. However, among all, silver is the best conductor. But because it is rare and a bit expensive, we normally use copper. So that has been for today. Otherwise, in our next lesson, we shall look at how we use the equation we have gotten, that's the formula for rate of heat flow, in solving calculations. Otherwise, I'm teacher Ivan from Wuna Educational Services. I hope to see you when you get back to us. Otherwise, please subscribe to all our YouTube channels, like and follow our pages on Facebook, TikTok, Instagram, and X. Otherwise, I hope to see you.